express the solutions as a product of linear factors. Let's look now at example number 1. X cubed minus 3x squared plus 4x minus 12 equals 0. Please take notes throughout this video. So we're going to take what we learned in Unit 5. Let's now list the possible rational real roots. So factors of 12 would include 1, 2, 3, 4, 6, and 12. Factors of 1, the leading coefficient, would be 1. So I'm going to test 1 and negative 1, 2 and negative 2, 3 and negative 3, 4 and negative 4, until I find 1 that works. Up until this point throughout Unit 5, we recognize that this would mean there's going to be 3 solutions. But in Unit 5, all of the solutions were real. They had no i's, no imaginary numbers with them. It's going to change in this unit. I'm going to start by trying 1. Okay, let's start by looking at 1. Now, if 1 is a solution to this polynomial equation, the remainder will be 0. So I'm going to use the acronym for synthetic division, MAMA, multiply, add, multiply, add, multiply, add, and so on. So I bring down the first number and I always multiply back to this number. 1 times 1 is 1, add down, multiply, add down, multiply, add down. This means 1 is not a solution. Let's test negative 1. So I bring down the 1 and I multiply, add, multiply, add, multiply. Negative 1 is not a solution. Let's test 2. Multiply, add, multiply, add, multiply, add. 2 is not a solution. Let's test negative 2. Multiply, add, multiply, add, multiply, add. Negative 2 is not a solution. Hopefully 3 or negative 3 works so I don't have to continue to test these possible rational roots. Multiplying 3, adding down to get 0, multiplying to get 0, adding down to get 4, multiplying to get 12, adding down to get, so 3 is a solution. So I know that one of the solutions is 3, and it tells me to solve the equation. That means I want to list the solutions. And then I'll go back and I'll express the solutions as a product of multiple linear factors. I'm going to take what I have remaining. 0 equals no x, 1x, 2x's, and I want to solve this. Well, 0 times x is simply 0. And I could go ahead and I could try to factor and go 1 times 4 is 4, multiplies to get 0, right? I could do that, but we'd see that it's not factorable. And so when it's not factorable, we can always rely on the quadratic formula, but in this case, when there's not a b value, because 0 times any value is 0, you're going to see that it's easier to simply use algebra to solve. So I am going to move over here so we can see this. I have 1x squared equals negative 4. Divided by 1 is not changing anything. I'm taking the square root. I'm going to have 2 answers. X equals plus or minus. Now we can't take the square root of a negative, so this is going to turn into an I, and I have x equals plus or minus 2i once I simplify. So I'm going to come back up here and write x equals 2i and x equals negative 2i. So for this polynomial equation, if we were going to turn y equals into this polynomial equation, when we set it equal to 0 is when we find the solutions, okay? But if we were going to actually graph this, we would only see one x-intercept. X-intercepts will only be the real solution. So this is a real solution. It contains no i's. These two are complex solutions. Complex solutions are not going to be visible on our graphs. Remember, when we graph, we're graphing on a real, this is a real axis here, so we have an x and a y. We don't graph complex numbers on a Cartesian plane, a real Cartesian plane. So these are my answers. Now, how do I go back and write this as a product of linear factors? X subtract, x subtract, x subtract. Now, in these spaces, I'm going to replace the spaces with 3, 2i, and negative 2i. So this equation would be y equals x minus 3, x minus 2i, Next, two negatives make it positive, plus 2i. This is a product of linear factors. This is the equation that has the solutions 3, 2i, and negative 2i. 3 solutions, one's real, and 2 are complex. Let's look at example number 2. So if we're provided this polynomial equation and we're asked to find the solutions, we're going to take the equation and we're going to replace y with 0. So I'm just going to put it in back here. I have a little more space. Now, I would write down, first of all the potential factors of 28. 1, 2, 4, 7, 14, 28, and all the factors of 1. So let's start by testing 1 and testing negative 1. 1, negative 11, 38, and negative 28. Okay. Once I bring down the first number, it's multiply and add. Multiply and add. Multiply. Oh, I got lucky. So I just tested 1 and it worked. So one of the 3 solutions is real. One of the 3 solutions is real. And the correct, and the solution is 1. Now I'm going to take this. This has no x, this has 1x, and this has 2x. So let's first of all see if we can factor to solve this. What multiplies equal positive 28 and combines to give us negative 10. So 1 and 28 would not combine to give you negative 10. 2 and 14, that doesn't work. 7 and 4, so this isn't factorable. Now just because it's not factorable doesn't mean we can't solve it. This problem is different than the previous example I showed you. In the previous example, remember we were able to eliminate the b term, and that's what made it easier to solve. When we have a trinomial and we can't factor, we can always go back to the quadratic formula. So I'm going to put parentheses wherever I want to drop in the values for a, c, and b. My b value is negative 10. Oh, you can't see anymore, sorry. Negative times a negative is a positive. Okay, so I'm going to come off to the side. This is called the discriminant. I'm going to come off to the side and do this. Negative 10 squared is 100. And then I have 4 times 1 times 28. So I know it's 4 times 1 times 28. Well, what's 28 times 4? 2 carried with 3 is 112. So inside of here, I have 100 subtract 112, which is negative 12, all divided by 2. And we just learned about complex numbers. And one of the ways here is we cannot take the square root of a negative. So this is going to come out front, and then the square root of 12 breaks into 4 times 3. Square root of 4 is 2. And now this 2 needs to be shared to both the left and the right. So 10 divided by 2 and 2 divided by 2. And don't forget, I forgot to attach that I. So when I simplify, I have 5 plus or minus 2 divided by 2 is 1. It's not necessary to put a 1 there, but here are our other 2 solutions. So one time I'm going to add, and one time I'm going to subtract. They're conjugates. Conjugates exactly the same in the front and the back, just one is addition in between and one is a subtraction. So I have 3 solutions. Out of the 3 solutions, 1 is a real solution. It contains no I, and 2 are complex. They contain i's. Okay, then we were asked to write the solutions as a product of linear factors. So to do that, let's see, I think I have space in here. I'm going to write y equals, and x subtract, and x subtract. So I'm going to drop in the 1 last. It doesn't matter if this goes in front or back. And then this is 5 plus I squared roots of 3 and 5 minus I square roots of 3. Lastly, we need to make this just a little bit prettier. We're going to take negative sign and distribute to both terms behind. So y equals, it needs to be left as a linear product of factors. So x subtract 5, subtract I squared to 3. X subtract 5, now two negatives make a positive, plus I squared to 3. And then x subtract 1. Let's take a look at number 3. So number 3 looks slightly different. We know there's going to be 3 solutions, but I only have 3 terms here. So to find the solutions, we're always going to replace y with 0. Now, I notice that I can factor out at most 1x. And I'd be left with x squared minus 14x plus 54. Let's look at this trinomial. What multiplies to equal 54 and combines to give us a negative 14? Well, 1 and 54 multiply to give you 54, but they don't combine to give you 14. Let's go 27 divided by 2. We have 27. 27 and 2 don't somehow give you 14. 3 and 18 getting closer, but doesn't give us the 14. So that doesn't work. We know 5 doesn't work. Let's try 6. 6 and 9 don't give us 14. So we're close. We're not able to actually achieve that. That means it's not factorable. So how do we go about finding these solutions? We're going to use the quadratic formula for this trinomial. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. 2 negatives make a positive. 14 squared, I want to make sure today I'm tired, is a positive 196. I'm going to drop down that subtraction time. Now I want to take 4 times 1 times 54. Okay, so I get 16, carry the 1. So this is subtract 216 all divided by 2. The difference between 196 and 216 is a difference of 20, but it's a negative 20 when we subtract. And now this is looking very similar to example number 2. Okay, so I'm going to split this. I'm going to take out the negative sign and make it an I. And 20 breaks into the square root of 4 times the square root of 5. I'm looking for that perfect square that nicely goes into 20. Square root of 4 is 2. And now this 2 must be shared to both the left and the right. So 14 divided by 2 and 2 divided by 2. 14 divided by 2 is 7. 2 divided by 2 is 1. And here are our other 2 solutions. So you're thinking, well, what happened to the first solution, right? So let's go ahead and let's write this down. X equals 7 plus, and I don't have to put a 1 there, but you can if you choose. There's one solution. There's the second solution. And the third solution is, we set this equal to 0, essentially. So when we set this equal to 0, and we solved using the quadratic formula, and we came up with 2 solutions. They're both complex. They both have i's. This is our other one. We're going to take x second equals 0 and solve. So for this polynomial equation, there are 3 solutions. One of the solutions is real, has no I, and 2 are complex. They contain i's. Lastly, I'm going to take these solutions and write it as a product of linear factors. The order you write these in does not matter. So x subtract 0, x subtract 7 plus I squared to 5, and x subtract 7 minus I squared to 5. So x subtract 0, you can write that down, or just x subtract nothing is simply x. And then x, I'm going to distribute the negative sign, x subtract 7, subtract I squared to 5, x subtract 7 plus I squared to 5. Let's take a look at another example. Alright, in this example, it's a little bit different other than it's pretty messy. 2x cubed plus 1x squared plus 4x plus 2. So now we have a leading coefficient that is different than 1. Okay, what we're going to do here testing here. 1 and negative 1, 1 and negative 1, 2 and negative 2, and then I'm testing 1/2 and negative 1/2, and then 2 and 2 just simplifies to 1. So let me press pause, and I'm going to test right now 1 and negative. So I only have 6 options, and I'm really hopeful that 1 or negative 1 of these integers will work. So let's drop down the first value, and then I'm going to start using synthetic division. I refer to as the MAMA method for an acronym: multiply and add down. Multiply and add down. Multiply, I can already see this doesn't work. 1 is not a solution. Let's hope that negative 1 works. So I'm going to multiply and add down. Multiply and add down. Oh, that doesn't work as either. Okay, well, let's hope that 2 works. I do not care to work with fractions if I have a choice here. Multiply to get 4, add down. Multiply to 10, add down. Multiply to 28, and it also does not work. Let's try 2. Multiply and add down. Multiply to get 6 and add down. This isn't looking good. All right, remember, we need to achieve an answer of 0. It's going to work. Okay, let's try 1/2. So half of 2 is 1, add down. Half of 2 is 1, add down. Half of 5 is 2.5. And I know when I add 2 and 2.5, I get 4.5. That doesn't work. Okay. This has to be a solution then. Half of 2 is 1, but there's a negative sign. I add down. Half of 0 is simply 0, and I add down. Half of 4 is 2, and there's a negative sign, and I finally achieve an answer of 0. Let's write this now. This has no x, 1x, and 2x. Now, this looks similar to the first example we did today in this video when there was no b value. So 0 times any value, any number, is 0. 2x squared plus 4 equals 0. I'm just going to use simple algebra to solve here. 2x squared equals negative 4. I'm going to bring it over here where I have a little more space to show you this. 2x squared equals negative 4. I'm going to divide by 2. X squared equals negative 2. I'm going to take the square root, but I can't take the square root of a negative. So x equals plus or minus. That's going to come out front to an I. And the square root of 2 can't be broken down. There's not a perfect square. Remember, perfect squares are 1, 4, 9, 16. The only perfect square that divides into 2 is 1, and that doesn't help us simplify anything. So this problem had 3 solutions. And I know one solution is positive I squared to 2. The other is negative I squared to 2. So I have 2 of the 3, but remember, I also found that I was able to take this rational root, and I can see that it works. So the other one is x equals negative 1/2. Okay, so what am I going to do with those? I'm going to grab a separate piece of paper because now I need to write these 3 solutions as a product of linear factors. So y equals x subtract, and x subtract. Dropping in negative 1/2, positive I squared to 2, and negative I squared to 2. 2 negatives make a positive, so x plus 1/2, x minus I squared to 2, and 2 negatives make a positive. We're almost done here. The very last step is if you have a fraction and it can't be reduced any further, so 1/2 can't be reduced, what would it look like if it could be reduced? Here's an example of something that could be reduced. Like, let's do like 10/5. 10/5 could be reduced to 2. 1/2 is in simplest form, but once it's in simplest form and it's still a fraction, you take the denominator and you push it in front. So 2x plus 1, x minus I squared to 2, and x plus I squared to 2.